Assalamu alaikum. Welcome to the video series on topical past paper questions of O-level physics 5054. Today in this video we'll discuss past paper questions of 2017 and 2018 related to the topic refraction of light and total internal reflection. So the first question for this video is from May-June 2018, paper 1, variant 1, question number 23. Which statement is correct? So you are given 4 statements which will be shown on your screens. So I would like you to pause the video and try to answer this question. Okay, so let's check all the statements one by one. Statement A is the total internal reflection only occurs when light travels from air into glass. This option is wrong because total internal reflection occurs when light travels from optically denser medium to optically rarer medium, that is from glass into air. So option A is incorrect. Statement B is the larger the refractive index of glass, the larger is the critical angle. Okay, let's check. You must be aware of the formula that sine of C, that is a critical angle, is equal to reciprocal of refractive index. So the larger the refractive index, smaller will be sine C because refractive index is in the denominator. So the larger the refractive index, smaller will be the sine of critical angle, and hence smaller will be the critical angle. So option B is also incorrect. Option C, when total internal reflection occurs, the angle of incidence is equal to the angle of reflection. Yes, that's right. That's absolutely right. When there is total internal reflection, the angle of incidence and angle of reflection are equal. Option C is correct, but let's check option D as well. When total internal reflection occurs, the angle of incidence is less than the critical angle. No, the total internal reflection occurs only if angle of incidence is greater than the critical angle. So option D is also not the right option. Okay, so now we have a question from May-June 2017, paper 1, variant 1, question number 27. Light traveling in glass is incident on a glass air boundary. The angle of incidence of the light is greater than the critical angle. Which arrow shows the direction of the light after it is incident on the boundary? Please pause the video and try to answer this question. Okay, the angle of incidence of light is greater than the critical angle, and light is traveling in glass, from glass to air. So whenever light passes from optically denser medium to optically rarer medium, which is the case in this question, and the angle of incidence is greater than the critical angle, total internal reflection occurs. And when total internal reflection occurs, the ray of light is reflected from the surface, satisfying the laws of reflection. Means the light ray will reflect such that angle of incidence is equal to the angle of reflection. So here you can see that this is the angle of incidence. This angle will be equal to this angle. So option B is the right answer. Next question is from the same paper, May-June 2017, paper 1, variant 1, and this is question number 28. Light strikes the top surface of a glass block at an angle of 15 degrees as shown. The refractive index of glass is 1.5. What is the angle of refraction R? Please pause the video and try to calculate the angle of refraction. Okay, I hope you would have done that. the light ray is passing from air to glass. So sine of I divided by sine of R will be equal to refractive index of glass. Now 15 degree is not the angle of incidence because angle of incidence is the angle between the ray and the normal to the surface. This angle is between the ray and this surface. So first of all we will see what is the angle of incidence here. Angle of incidence will be this one, the angle between incident ray and the normal, and this angle is 90 degree. So angle of incidence will be 90 degree minus 15 degree is equal to 75 degree. So we will write here sine of 75 degree divided by sine of R is equal to refractive index of glass is given as 1.5. So sine of R will be equal to sine of 75 degree divided by 1.5, and R will be equal to sine of inverse sine of 75 degree over 1.5. It becomes R is equal to sine of inverse of 0.64395, and it is 40.08 degree. Option C is the right answer. Okay, the next question is from October-November 2017, paper 1, variant 1, question number 20. A solid plastic cylinder is immersed in a liquid of refractive index 1.4. Light traveling in the plastic cylinder strikes the inside surface at an angle of 70 degree. The light undergoes total internal reflection. What are the values of the critical angle in the plastic and the refractive index of the plastic? Okay, please pause the video and try to answer this question. Okay, so the light undergoes total internal reflection. Remember that total internal reflection occurs when the light passes from an optically denser medium to optically rarer medium. Means from a medium of high refractive index to a medium of relatively less refractive index. So the refractive index of plastic will definitely should be greater than 1.4. Option A or option C. Now, secondly, total internal reflection occurs when angle of incidence is greater than the critical angle. Here, total internal reflection occurs at angle of 70 degree, means 70 degree is greater than the critical angle. So, critical angle in plastic should be less than 70 degree. So, option C is the right answer. Okay, next question is question number 21 from October-November 2017, paper 1, variant 2. Light is incident on a plastic block of refractive index 1.5. The angle of incidence is 50 degree. What is the angle of refraction? We have done a similar question, so I hope you would be able to do this question. Please pause this video and try to solve it. Okay, so sine of I divided by sine of R would be equal to the refractive index of plastic. Angle of incidence is given as 50 degree, so sine of 50 degree divided by sine of R is equal to 1.5. So sine of R will be equal to sine of 50 degree divided by 1.5. If we calculate it and if we take sine of inverse of this value, it comes 30.7 degree. Option A is the right answer. Next question is question number 22 of the same paper, and this is the same question as we have done in the variant 1. So let's skip it. Take care. Allah Hafiz.